Ladies and gentlemen, hello and welcome to our CAMIT webinar on our CAMIT ceramic safety capacitors. My name is Alexander Nebel and I will moderate the webinar today. We are very pleased that you find the time to join our webinar. Presenter is Mark Labs, our product manager for MLCC. Before we start our webinar, I have some information. We invite you to ask us questions. You can address your questions at any time during the webinar with the chat function on the right-hand side in your browser. We will answer all of your questions at the end of the webinar. Also, no need to take notes. We will publish the presentation afterwards. Hello Mark, thank you for presenting again today. Please tell the audience shortly about your role inside CAMIT, and then you can start your presentation.
Thank you. How's the audio? Does it come through okay?
Yes, I can hear you perfectly.
Excellent, thank you. So again, my name is Mark Labs. I'm a technical product manager at CAMIT. I've been here for about 13 years. Main background is in electrical testing, and then I moved to the product management group for about 3 years. And main tasks are customer support, launching products, and then putting on nice technical webinars. So we hope you find this webinar useful. And today's titled Ceramic Safety Capacitors, Avoiding the Confusion. And the purpose of this webinar is to really help understand the background of safety capacitors. And sometimes there's a little bit of confusion with safety capacitors. And one of the confusing aspects is, for some people, is why they even exist, right? So, we call them safety capacitors, but are their main functions to keep you safe, right? Does designers select these capacitors as their primary function to keep a user safe? And the answer is no. That's not why they're being used. So today we're going to cover what are safety capacitors, the certification and classification of them, disc lead types, surface mount MLCCs, CAMIT ceramics offering, and then some key takeaways. Okay, so electronics are a major part of everyday life and usage continues to grow. Now, whether someone's using a small consumer device such as a cell phone or a high-power electric vehicle charger, each one of these devices must obtain their power from some power source, such as a wall outlet in the home or your business. Now, the term mains or mains voltage refers to the electrical power that is delivered to homes and businesses, and it's the main form of electrical power that consumers use when you plug in a domestic appliance, television, electric lamps into these wall outlets. Now, power in the home can be thought of as a network of multiple devices connected together on the same AC voltage line. Now, since these devices are on the same power network, the devices can affect one another. Now, therefore, it's important that there's proper isolation between all of these devices. Now, many devices in the home, such as chargers, TVs, appliances, computers, contain high-frequency switching components like transistors. Now, because of the high-frequency switching, these devices can generate high-frequency electrical noise called EMI, or electromagnetic interference, in the tens of kilohertz to megahertz frequency range. Now, the EMI generated by these devices can be induced on the main voltage and be distributed throughout the home's power network. Now, because other devices are connected on the same network, they may be affected by the EMI that's been induced on the AC mains, and their performance may be degraded. Now, in addition to EMI, lightning can occur around the home and induce high voltage transient spikes on the mains voltage lines. Now, these high voltage transients can be distributed throughout the home's power network and damage all those connected devices. So knowing that many devices can generate unwanted EMI, how is EMI reduced as to not affect other devices? And this is where AC line filters are commonly used. But how do these work? Well, in this example, the EMI filter is used at the input of the dryer's power circuit and contains inductors and capacitors. Now, EMI filter inductors are commonly called chokes as they choke or prevent sudden current changes. Now, the inductor has a low impedance at 50 and 60 hertz, which allows the useful power to pass on through to the dryer. But at high frequencies where the EMI is present, the inductor has a high impedance, which helps block that EMI from passing on through and getting to the dryer. Now, in addition to the inductor, capacitors are placed between the line and neutral and line to ground. Now, capacitors that are connected from line to line or line to neutral are called X capacitors. Capacitors that are connected from line to ground are called Y capacitors. Now, at 50 and 60 hertz, the capacitors have a very high impedance, which has no effect on the AC voltage. But at high frequencies, the capacitors have a low impedance, which shunts the transient currents to either neutral or ground. Now, important observation in this example is that the ground connection of the filter is connected to chassis ground of the dryer, which is the external metal enclosure. So in any circuit design, the question must be asked, what happens if a component fails in the circuit? Now, considering the dryer example, the input is connected to a 240 volts AC high voltage source capable of delivering up to 30 amps, which is very dangerous. Now, since X capacitors are directly across the line to neutral, the capacitor is seeing the high AC voltage over the entire lifetime of operation of the dryer. Now, if an X capacitor were to fail, the 240 volts AC would now be shorted to neutral, which will either blow a fuse or result in a fire. Now, if a Y capacitor were to fail, the ground connection of the dryer were compromised, the 240 volts AC would now be on the chassis ground that is connected to that metal enclosure. This would result in a scenario of the metal enclosure being energized by the high AC voltage and risking electric shock to the user. Now, therefore, it can be assumed that the reliability of X and Y capacitors for AC line filtering are critical to the safety of the user operating the device. The capacitor must be able to not only operate under constant high AC voltages, but also survive transient voltage spikes due to lightning surges. Now, knowing how safety capacitors operate and the importance of the reliability under high AC voltages and lightning strikes, a proper definition of safety capacitors can be provided. Now, safety capacitor is a capacitor that is designed to aid in the filtering of AC line voltages and can be safely used on line-to-line and line-to-neutral and line-to-ground applications. These capacitors must be able to properly filter out EMI, be able to survive high voltage transients such as lightning strikes, and operate reliably under high AC voltages. Now, even though many people call them safety capacitors, it's also acceptable and probably more accurate to call them interference suppression capacitors because they suppress interference or suppress that EMI. Another key feature is that these capacitors, that they're qualified and certified to internationally recognized standards. Now, to ensure safety capacitors are reliable for the line-to-line and line-to-ground applications, they must be certified to internationally accepted standards. Now, the main standard for safety capacitors is the IEC 60384-14, which is titled Fixed Capacitors for EMI Suppression and Connection to Supply Mains. This is an internationally recognized standard and is referenced by all suppliers who produce safety capacitors. Now, UL also adopted this standard to create the UL version, but it's pretty much identical to the IEC version. There's only a few minor deviations. Now, IEC 60384-14 provides strict requirements for classifying, qualifying, testing, and marking of the safety capacitors. The classification, such as X1, X2, is defined within the standard, and the capacitor suppliers must meet the specific requirements to classify to those ratings. In addition, the qualification and test procedures are defined within the document to ensure all certified capacitors meet the strict requirements of the standard. These include electrical and mechanical tests, solderability and impulse voltages, endurance testing, active and passive flammability, just to name a few. The standard also defines the marking for these capacitors, and suppliers must adhere to them in order to certify them to the standard. Some of the markings seen on safety capacitors may include, but not limited to, supplier trademark, capacitance code, voltage class, and certification body. Smaller disc and surface mount capacitors are too small to print these markings, so the IEC standard provides guidelines on what markings are required. So per the IEC standard, safety capacitors are divided into two classes, X and Y. Now remember, X capacitors are connected from line to line or line to neutral, and Y capacitors are connected from line to ground. They are further divided into subclasses such as X1, X2, Y1, Y2. Now for each subclass, AC voltages are designated to provide the overall capacitor class and voltage rating for the application. For example, a typical safety capacitor can be listed as an X1 400, Y2 250. This means that the customer can use the part type as an X1 capacitor at 400 volts or a Y2 capacitor at 250 volts. Each of these subclasses has a peak voltage, rated voltage, application, and impulse voltage rating requirement that are specified by the IEC safety standard. Now, it's common for customers to substitute class and voltages for others, but there are substitution rules provided by the IEC standard. For example, if a Y2 capacitor is not available, you can actually use a Y1 capacitor in its place, but you can't do the other way around. So you can just refer to the standard on those rules. Now, certain applications may require interference suppression for DC line voltages and also have a safety certification. Now, the IEC standard allows for the AC rated safety capacitors to be used at DC voltages up to the RMS voltage rating. For example, a Y1 capacitor at 250 volts AC can be used as a Y1 capacitor at 250 volts DC. Now, some suppliers, we can rate these to higher voltages, but we have to go through a qualification. But if you purchase any a safety capacitor with an AC voltage, you can use it at the RMS rated voltage at DC. Now, historically, all ceramic safety capacitors were in a leaded disc form factor. Now, it's common for leaded disc safety capacitors to come in multiple lead style configurations, and the most common are straight, outside kink, inside kink, and vertical kink, which is also called inline kink. Each of these lead styles is a modification to the lead form and not to the actual disc itself. Now, the various lead styles that are available provide different mounting options. The straight leads will seat all the way down to the lower portion of the disc. This means that the capacitor will either touch the PCB or the assembler must hold it above the board while soldering, which can lead to inconsistent mounting heights. When choosing a kinked lead style, the capacitors can seat on the circuit board at a consistent height without the bottom of the disc touching the PCB. Now, each kink lead style, whether outside, inside, or vertical, provides that benefit. Now, when comparing the outside kink versus the inside kink, there are some considerations for both of these lead styles. For the outside kink, on some part types, the distance between the kinks will exceed the diameter of the disc and may cause issues with board space and adjacent components. In this case, designers may want to choose the inside kink to avoid that. Now, when you use the inside kink on some part types, it's possible that the distance between the leads violates that clearance space distance requirement specified in the IEC standard. Now, users of safety capacitors must consider clearance distances when selecting lead styles to avoid violating the safety standard. Now, in this slide, a comparison can be made between the straight lead and the vertical or inline kink. Since disc capacitors have some distance between the electrodes and the lead wires are soldered to those electrodes, this offsets the leads by some distance. Now, when mounting on a circuit board where space is a concern, this causes the lead disc to be rotated. In the vertical or inline kink, the leads are bent to be in line with one another and allows the disc to have no rotation on the PCB and keep the mounting holes directly under the capacitor for very high density mounting. Now, ceramic safety certified disc capacitors are constructed using a single layer capacitor in the form of a disc with lead wires attached using a lead-free solder joint. After assembly, the capacitors are coated with a fire retardant epoxy encapsulation material. Now, in November of 25th of last year, Kemet announced the CAS Surface Mount Capacitor Series, which is available in X1, Y2, and X2 classifications. These are high reliability BME technology, 250 volt rated with peak impulse voltages capable up to 5 kilovolts, available both in C0G and X7R dielectrics, case sizes ranging from 1808 to 2225. Now, safety certified capacitors available in these multi-layer form are constructed using alternating layers of ceramic dielectric with metal electrodes, similar to other MLCCs. Each capacitor layer represents a single capacitor, and adding more layers adds more capacitance to the MLCC because they are in parallel. Now, because these are very high voltage capacitors, we employ a serial electrode design, which is normally fail open. There's a lot of concerns about flex cracks out there. These are normally fail open devices, which is desired in a in an environment where flex crack is a concern. MLC safety certified capacitors provide a much smaller form factor than leaded disk capacitors, and also can be surface mounted using industry standard reflow profiles. So the major push to move to MLCCs back in the 80s and 90s was about smaller form factors, as small as possible in high density applications. And the same thing here is happening to safety rated capacitors. When you have bulky disk capacitors, you can now move and go to that miniaturization trend that everybody desires, and also avoid having two different reflow types that you have to, or processes that you have to go through. With a disk capacitor and you have MLCCs on the board, you have to do two different reflows. You have to do the MLCCs, and then you have to either hand solder or solder wave the disk capacitors on there afterwards. With the MLCC form factor for safety capacitors, you can do the entire assembly just as you would any other MLCCs. Solder reflow profile is exactly the same as other MLCCs that are used, so it's one process, which is a cost savings. Now, these are available in standard termination. No flex term options are available at this time. And here's the ordering code that you can see here. We call this the CAS Series with 4 different case sizes, and it follows a very similar part number structure as other Chemet part types. You have 2 subclass definitions, X1, Y2, and X2. Again, these are rated to 250 volts. And if you're interested in the certificate for the certification, you can find those directly in the data sheet. There are links directly to the UL and TUV certifications. You don't have to request that from sales. They are available online. We do have samples available in Mauser and DigiKey, so those are ready to go. You can order what we have a stocking package online, and you can order those immediately. So Chemet offers 4 safety certified series for interference suppression. The C900 safety disk series, which comes in 5 voltage classes in 3 lead styles and certified by UL and VDE. The ER safety disk leaded series comes in 3 voltage classes in 3 lead styles and is also certified by UL and VDE. The KJ safety disk series, which comes in 2 voltage classes, 3 lead styles, and certified by UL and TUV this time. And the CAS surface mount series, which comes in 2 voltage classes, 4 case sizes ranging from 1808 to 2225, and certified by UL and TUV. Okay, so what are the key takeaways from today's presentation? Well, safety capacitors or interference suppression capacitors are used for filtering of EMI on AC mains and designed to be very robust to protect the users from failure. All safety capacitors should be certified by an approved certification body for using the IEC 60384-14 specification. Designers must look for the appropriate marking and certificate to verify that capacitors they're buying are certified. Chemet offers both X and Y capacitors with a variety of lead styles, and the Chemet CAS safety certified MLCCs provide opportunities for miniaturization as compared to the leaded disk form factors. Well, thank you everybody for listening to today's presentation. I think we can open it up to questions.
Yes, hello Mark. Thank you. We received some questions. Also the information that your voice was a little bit quiet. I hope it's not a technical issue. So the first question, and this is a question which I did not directly receive in this call but before, but it's very interesting, and especially for the SMD capacitors. How would you propose to handle the mechanical stress potential issue for such big capacitors? So what mechanics does Chemet employ to protect against mechanical stress?
So we do have FlexTerm on our roadmap. That is something that we want to develop because we know customers are concerned about flex cracks. But there are mitigation techniques for any MLCC, not just safety capacitors, but MLCCs in general, to avoid flex cracks. The orientation of mounting, the location on the board relative to scoring marks or break points, the location relative to screws or any areas on the board that can be flexed mechanically, for example. And one of the major concerns for flex cracks is shorting. But the good thing about safety capacitors is because the inherent high voltage designs, we have to use a serial or floating electrode design, which inherently fails open. So those are some of the concerns that can be mitigated. But for example, like any other MLCC, you want to go through the steps to mitigate your risk of flex cracks.
Okay, thank you for this information. The next question is a very simple question. Are the safety MLCCs available as samples?
Yes, so that's why we have them in Mouser and DigiKey, so you can get them through our distribution hubs, our distribution channels, so Mouser and DigiKey, and I think we have one more. But if you do want samples, you can contact sales, and then we can go ahead and give you samples at no cost.
Okay. Our next question, which were our failures do you which wear out failures do you see on the ceramic capacitors? I have heard they normally short at the end of life.
Well, that's a good question. So, ceramic capacitors in general are very robust, and the wear out. So when certain capacitor technologies, the wear out is in the tens of thousands to hundreds of thousands of hours. So you're kind of in that window of concern. MLCCs have a very long wear out. So when you just talk about, if you get past all, that low failure rate, and you get to that wear out region where you start to get, that curve starts to go up and you get more and more wear out. That's very, very far in time. So rarely will you ever see MLCC, that population, wear out like you're going to see in other capacitor technologies. That being said, if you ever to reach wear out of these type of MLCCs, they are a fail-open design. So you would have to basically have a dielectric breakdown in between all of the different serial connections in order to have a short, which is one of the primary benefits of a technology like this, is because of those designs that are employed, you're never going to see that. And there's a lot of concerns out there over MLCCs and line applications, which is why you have these tests. You would think 60 hertz is not a huge deal, but it is for certain technologies. So, for example, we don't recommend X7Rs for line applications. That being said, you can qualify certain X7R technologies, such as these capacitors and our non-safety, or we call our AC certified series, for AC line applications, but you have to go through the qualification process for the specific application. So these capacitors, because they're designed for line applications, very high voltage for a long period of time, and lightning surges, they're actually very conservative designs, which is why you don't see a large capacitance range in them. So very, very conservative, very thick active layers, and they pass a very strict qualification by the IEC 60384-14 standard.
Okay. So it seems for the moment these were all the questions we had. So to all the audience, if you have any more questions, you can contact Mark Labs. You can see now his contact on the screen. You can also contact your local sales or FAE from Kemet. And to you, Mark, thank you for presenting today. Very interesting products. I'm happy to see more about this and to see also maybe some flex termination, which is on the roadmap. And yeah, thank you for today presenting, and have a nice day.
Thank you. Have a great day.
Okay, goodbye.
Take care. Bye-bye.